All right, so I have a problem up here that I'm going to work with you and show you the strategies on how to solve ratio word problems using bar models. And this is only part one because part two is going to talk about what happens when the ratio changes. So right now we're just doing bar models with ratio staying the same. So please write down the problem that I've prepared, and then I don't have any questions on here yet because we're going to answer the questions as we go along. So the first problem says Megan prepares a fruit punch using apple juice and orange juice in a ratio of 4:3. Anytime a problem gives me a ratio, and I showed you this a little bit when we were doing practice yesterday, of how I like to write what comes first. So in this case, apple juice to orange juice, and it's in a ratio of 4:3. I rewrite it like this because it's going to help me when I am using my bar models. I'm going to start by drawing a bar model of 4:3. To show my ratio. This ratio doesn't tell us anything about how much she makes total, if she's making ounces, if she's using milliliters. It just tells us the ratio is 4:3. All right, so now I'm going to ask a question. My question is, if Megan makes 630 milliliters of fruit punch, how many milliliters of apple juice does she use? So what it's telling me is that this whole picture here that represents all of the fruit punch she's making, this whole thing is equal to 630 milliliters. And so what I need to figure out is how much of the apple juice she used and how much of the orange juice she used. So I'm going to count up my boxes. 1, 2, 3, 4, 5, 6, 7. She has 7 boxes, and those 7 boxes are worth 630 milliliters. So I'm going to figure out what each box is worth. So I'm going to take 630, divide by the 7 boxes to tell me what each box is worth. 7 goes into 63 9 times. 7 goes into 0, 0. So she uses 90 milliliters per box. And now that I figured that out, I can figure out how much apple juice she uses. So apple juice is equal to 90 times 4 boxes, which is 360 milliliters. Now I'm going to change it. I'm still going to have an apple to orange juice ratio of 4:3. But now I am going to use $520 milliliters of apple juice. How much fruit punch is made? So Megan is using 520 milliliters of apple juice. How much fruit punch is made? So I want to figure out what this total is, and I can figure that out by knowing one piece of information. These 4 boxes are worth 520. So what will each box be worth? So I'm going to take 520 divided by the 4 boxes, because those 4 boxes represent the apple juice only. And I get that each box is worth 130. Which means the orange juice are also worth 130. Now that I know that, I can figure out the total amount of fruit punch. Remember, I had 7 boxes, and each of those boxes are worth 130. She makes 910 milliliters of fruit punch. All right, so that's our first problem that shows us how to use bar models to solve problems. And again, you might have been able to figure this out without a bar model. However, I would like you to use bar models because our ratios are going to get harder and they're going to change. And we are going to represent the change with our boxes. So I'm going to flip my page and do another example because I'm out of room. All right, here's our problem. A box contains baseball and football cards in a ratio of 5:1. So baseball comes first, so baseball is 5. Football comes second, so it is 1. So I'm going to write baseball, football, and I'm going to rewrite my ratio 5:1. And then I'm going to draw my boxes. Five to 1. Now I'm going to answer some questions. The total number of cards is 1,380. How many of each type of card are there? So it wants to know how many football and how many baseball. So all of these boxes represent 1,380 cards. So I have to count my boxes. 1, 2, 3, 4, 5, 6. I also know that if I add 5 and 1. And I'm going to take my whole number and divide by the amount of boxes to figure out which each box is worth. So 6 into 13. I hope you're doing this along with me. Each box is worth Now there's two ways that I can figure out how many baseball cards there are. Because I only have how many baseball cards there are. Because I only have one box here, obviously I know that there are 230 football cards. And in order to figure out baseball cards, I can either take 230 and multiply it by 5, or I can subtract 230 from my total. Either way works. So now I have my answer. Now I'm going to switch up the question just a little bit. We're still in a 5-to-1 ratio. So I'm going to redraw my boxes because I'm going to need them. And this now tells me that there are 950 baseball cards. How many football cards are there? So I'm only looking at baseball cards right now. So these 5 boxes represent 950. So I take my 950 and I divide by how many boxes are represented by those 950. And that tells me what each box is worth. And once I find out what each box is worth, then I know automatically how many football cards there are. I'm going to give you one more example, and this is with a ratio that has 3 quantities because we haven't really worked with those. Alright, I'm going to try to make this problem a little bit shorter so you have a little bit less writing. Jenny makes a ceramic jar with feldspar. Feldspar is a mineral. Red iron oxide, also a mineral found in nature. And silica, another mineral found in nature. So she's making a ceramic jar with all three of these minerals mixed together into a clay. In the ratio 5 to 2 to 3. Ooh, the light just went off. Okay. Sorry. The mass also means weight, of the mixture is 1 kilogram, 200 grams. What is the mass of each ingredient? Jenny makes a ceramic jar with feldspar, red iron oxide, and silica in the ratio 5 to 2 to 3. The mass of the mixture is 1 kilogram, 200 grams. What is the mass of each ingredient? There are a couple things I need to do before I start solving this problem. The first thing I'm going to do is I'm going to turn this amount, 1 kilogram, 200 grams, into just one unit because I have kilograms and grams. And by looking at page 276, like we did, or looking in your notebook because we pasted it in, it tells me that 1 kilogram equals 1,000 grams. So 1,000 grams equals 1 kilogram. So I'm going to add 1,000 grams here and 200 grams here for a weight of 1,200 grams. Total. Now I'm going to do my mixture. 5, 2, 3. 5 is the feldspar. 2 is the red iron oxide, and 3 is the silica. And you can label these however you want. I just usually use the first letter from whatever it is to help me remember. And now I'm going to draw my boxes. Remember, 4 cuts gets you 5 boxes. So I have 5, 6, 7, 8, 9, 10. I have 10 boxes. And I have 1,200 grams. Ten into 12 goes once. 10 into 20 goes twice. 10 into 0 is 0. So each box is worth 120. And you don't have to write the number in the boxes all the time. I just do sometimes to help me. So the question is, what is the mass of each ingredient? So feldspar, red iron oxide, and silica. So feldspar is going to be 120 times 5. I hope you're doing the math. 12 times 5, add a 0, so 600 grams. Red iron oxide is 120 times 2. And silica is 120 times 3. And if you add all of these up, it should equal the 1,200 grams that we started with. All right. That is our notes. However, I'm going to give you a to-do. And I'm going to try and make it short. A school fundraiser made $18,000. The money was divided by the student council, band, and science camp fund in a ratio of 1 to 2 to 3. How much money did each group receive? So your job is to find out how much money each group received by using the models that I just showed you how to do. And again, student council, band, and science camp is 1, 2, 3. So student council gets 1 part, band gets 2 parts, science camp fund gets 3 parts. Make sure you show me how you solved the problem and be prepared to talk about it tomorrow.